Hey guys, this is question MM029 in the 2017 Maths Methods Sharpen Study Guide. How to solve two simultaneous linear equations when they have no solutions. We've got a value of m in there as well. So if you haven't already and you're a little bit unsure about these sort of questions, have a look at the other video that I've done on this with a bit more explanation in it. Or you can have a look at the front of the Sharpen Study Guide and it has a bit of a run through on these sort of questions. So, firstly we need to recognize that these two equations are not in the same form and therefore they're not comparable. So let's try and make them comparable by getting them in the same form. So our first equation is m plus 2x take 2y equals negative 1. And we want to get that into the form y equals mx plus c. And if we get both of them into that form, it's going to be a lot easier to see what's happening. So we basically want to get y by itself. So we get negative 2y equals negative m plus 2x take 1. And then if we divide both sides by negative 2, we get m plus 2 over 2x plus 1 over 2. Now for our second equation, we know that the second equation is 2x plus m take 3y equals 2m. And if we want to get y by itself, we simply take x over the other side. We get negative 2x plus 2m. And if we divide both sides by m take 3, we get negative 2 over m take 3x plus 2m over m take 3. And these are our two equations. Now, we know that two simultaneous equations, or linear equations rather, have no solutions when their gradients are the same and their c values are not the same. So these two values here, this and this, are equal to each other, and this are not equal to each other. So what we need to do is find out the values of m when those two gradients are the same. So we simply equate the gradients. So we have m plus 2 over 2, which is this gradient here, equals negative 2 over m take 3. And the reason we can do that is because we do have it in the form y equals mx plus c, and it's a lot more comparable. So now we simply cross multiply. We get m plus 2 times m take 3 equals negative 2 times 2, which gives us negative 4. And on this side we expand that out, get m squared take m take 6 equals negative 4. And if we get everything on one side, we get 0 equals m squared minus m, with plus 4 to that side, which gives us take 2. And if we factorize that out, we get m minus 2 m plus 1, which means that m equals 2 or m equals negative 1. So that tells us that when m equals negative 1 and m equals 2, the gradients of these two linear equations are exactly the same. So now we need to find out which values which value of m makes these two c values different, because we want them to be different for no solutions. So what we then do is we have our c values, 1/2 equals 2m over m take 3, and we basically want to sub m values into that. So we then have 1/2 equals, so when m equals negative 1 to start with, 1/2 equals 2 times negative 1 over m take away negative 1, negative 1 take away 3, which gives us negative 2 over negative 4, which is 1/2, and this side is equal to 1/2 as well, which means that c1 equals c2 when m equals negative 1, which is not actually what we want. That would give us infinitely many solutions. So we would assume that when m equals 2, that's going to give us no solutions, but we still need to check anyway. So we do the same thing. 1/2 equals 2 times 2 over 2 take 3, which gives us 4 over 2 take 3, which is negative 1, 1 over 2, and that is clearly different, which means that c1 does not equal c2 when m equals 2. Which is good, that's exactly what we want. So that means that there's going to be no solutions because m1 equals m2 and c1 does not equal c2. So when m equals 2, that's when we have no solutions, giving us our answer E.